Okay, guys, good morning. So welcome to our fourth and final day of writing equations to model word problems. Now, we will do other word problems in the next couple weeks, but as far as specifically writing kind of two-step and multi-step equations, today's going to be the last of these 4 days. So I think we'll just, because we have a lot to do with the lesson itself, let's just do number one. For the do now, so it says together in a pencil and a sharpener cost 91 cents. The sharpener is 6 times as much as the pencil. So I'm going to say let X represent the cost of the pencil. And it says the sharpener is 6 times as much, so we'll call 6X the cost of the sharpener. And it says together they both cost 91 cents. So the pencil plus the sharpener all together cost 91 cents. So we divide both sides by 7. It gives me X is 13. I also need to find out what 6X is. So 6X is 6 times 13, which is 78. So our answer as a question would be the pencil costs 13 cents and the sharpener costs 78 cents. So today we're going to focus more on finding numbers, right? It's not going to be so much of a real world context where we're finding the values of things, even though we'll see that maybe a little bit with our homework or our work period. Finding numbers based on number relationships. So this one is a little bit simpler, right? So we don't even really need a let statement, right? A number is decreased by 7. The new quantity is tripled, giving us 15. What was the original number? So I don't really need to say let X represent the number, even though it's there. So let's go through it sequentially. My number, X, decreased by 7, X minus 7. This new quantity is tripled. In order to triple X minus 7, we need parentheses, and the new value is 15. Okay, we should be able to solve this pretty easily at this point. All right, so 3X equals 36, so X is 12. All right, so when we check it, we say, okay, what happens if 12 is decreased by 7? Well, 12 minus 7 is 5, and if you triple 5, we get 15. All right, one number is 10 more than another. The sum of the numbers is 70. What are the numbers? All right, so we're going to say let X represent, I could say the first number or the smaller number. Either one is fine. And it says one number is 10 more. Well, if X is the smaller one, and there's another number that's 10 more than X, then we're going to call that X plus 10, and that's always going to be our larger number. All right, so that's not so bad. Not so much different than what we did with the last lesson. And the sum of these two numbers is 70. So X plus 10 is 70. Sometimes teachers will put the X plus 10 in parentheses. I don't do that because my experience has been if kids see parentheses, we feel like we have to distribute something, so we end up distributing things that aren't there. So I don't use the parentheses for that reason, just in case you were looking online or in a textbook or something, right? So X plus X is 2X plus 10 equals 70. Right, so that's going to give me 2X is equal to 60, which means X is 30. And of course, we have to go back and find X plus 10. Well, if X is 30, X plus 10 is 30 plus 10, which is 40. So to answer the question, right, it's a little bit easier to TTQA, right, turn the question around here. We'd say the numbers are 30 and 40, right? We don't say the cost of the pencil and the cost of the sharpener. We can write a very simple sentence. The numbers are 30 and 40. All right, this is just kind of the opposite, right? One number is 12 less than another. So I'm going to say let X represent the larger number. And there's a number that's 12 smaller, so we're going to have to call that X minus 12, and that's going to be the smaller number. All right, now those of you that are really kind of thinking ahead here are going to say, well, I don't like using subtraction. I'd rather use addition. If one number is 12 less, then it means the bigger one is 12 greater. So we can make X the smaller and make X plus 12 the larger. So we can do it that way as well. And again, the sum of the two numbers is 86. So X, the sum means to add. So X plus the quantity X minus 12 equals 86. So X plus X is 2X minus 12 is 86. All right, so 2x equals 98. That tells me x is 49. And I need to find x minus 12. So x minus 12 is 49 minus 12, which is 37. And if I add 49 and 37, I get 86. So again, to answer the question, right, what are the numbers? We would say the numbers are 37 and 49. All right, guys, I am going through this a little quickly, like I tend to do sometimes, but again, one is because we have a lot to do and I don't want this to be a 20-minute video, right? I like to try to keep you engaged for a fairly limited amount of time. That way you have enough time to go off and do the work and we don't get kind of bored and disengaged. And also, guys, if you need to, you pause it. You go back, you copy, you take your notes, okay? We're still going to do the notebook check every Friday, so make sure that we are taking those notes. All right, so this one's a little different, right? It says one positive number is twice another. Now it says the positive difference. And we say, well, what the heck does that mean, the positive difference? Well, given any two numbers, okay, if I say what's the difference of these two numbers, someone could say 4, and I could argue that it's negative 4, and there's no way to prove who's right, okay? The difference can be taken, if we say what's the sum, it's 10, right? There's no argument. The sum is 7 plus 3 or 3 plus 7. The commutative property tells us it doesn't matter. It's 10. If I ask you for the difference, right, again, 4 and negative 4 are equally valid. Now, if I say the positive difference implies that we do the bigger number minus the smaller number, okay? Otherwise, it's going to be negative, right? If I take smaller minus larger, regardless of the signs of the numbers, my difference is always going to be negative. So we're going to have to take that into account a little bit here when we set up this problem. And also it says that the numbers are positive. So we're going to say, okay, one number is twice another. So twice means 2 times. So let x represent the smaller number. And let 2x represent the larger number. Now the strange thing here, I guess it's not that strange if you think about it, is if the numbers were negative, x would be the larger number. Because if x turns out to be negative 50 and 2x turned out to be negative 100, that's the smaller number. So with negative numbers, the positioning would switch. So I kept it pretty simple, positive numbers with positive difference. Okay, so what does it mean that we want the positive difference? So again, it means we're subtracting the smaller number from the larger. So assuming these are both positive, which it says they are, 2x minus x will be positive, whereas x minus 2x will be negative. So 2x minus x is x, so x is 40, and 2x is 80. So honestly, guys, you probably could have solved the problem without me going off on that little tangent about positive differences and things like that. But it is something that eventually, when we get to kind of higher level algebraic kind of word problems, it's going to be important. So it was good to kind of introduce it now. So one number is twice another, 80 is twice 40, and the positive difference when I do 80 minus 40 is 40. Okay, so now there's a two-step problem. So not that different than the ones we did in the last lesson. So I'm going to have one of my numbers. So it says one number is 20 less than 3 times another. So if my first number is x, the other one is 3x minus 20. So here's something that's a little interesting about this problem. Okay, I'm going to say the first number and the second number. And the reason I'm going to say that is I don't know which number is greater. In other words, if x was 5, let's say, then 3x minus 20 is going to be negative 5. X is going to be bigger. Whereas if x is 100, 3x minus 20 is going to be 280. That's going to be much bigger. So we can't necessarily say, and it doesn't matter in the problem, right? So those are our two expressions, right? 20 less than 3 times x is 3x minus 20. And we know that the sum of those is 80. So that part of the problem has been pretty consistent. The sum of x, right, and added to, so addition, the quantity 3x minus 20 is 80. Okay, well, x plus 3x is 4x, which means 4x is equal to 100, which means x is 25. Right, and if x is 25, we need to do 3x minus 20. I'm going to put that up here because some of us, I gloss over this a lot when I do this in class, and I always have one brave student eventually will say, well, where did you get that answer from? Because we all do the substitution in our head, but, not everyone understands that. All right, so where did I get this 55 from? I got it by substituting x is 25 into the expression 3x minus 20. So what are the numbers? Well, let's answer the question, right? TTQA, the numbers are 25 and 55. And if we add 25 and 55, we get 80. If we want to check if one number is 20 less than 3 times the other, we do 3 times 25 is 75. 75 minus 20 is 55. All right, guys, challenge time. So I wouldn't be doing this if I didn't think we were ready. So let's see how this goes. We've got 3 numbers. Okay, so I'm going to call x the first number, and then we're going to see where we stand with this. I'm going to do some abbreviating. The second number is 3 times the first. All right, so far so good, right? So my second number is 3 times my first, which was x, so 3x. Okay, that's doable so far. And now it says the third is 5 less than the second. Okay, that seems doable also, right? So if the second number was 3x, then the third is 5 less than that, so 3x minus 5. Okay, so not terrible. And the sum of all of these numbers is 79. So the first number plus the second number plus the third number equals 79. So x plus 3x is 7x minus 5. Right, so that gives me 7x equals 84. So that gives me x is 12. And if x is 12, what's 3x? It's 3 times 12, which is 36. What's 3x minus 5? Well, I just proved that 3x was 36, so 36 minus 5 is 31. Right, so what are the numbers? The numbers are 12, 31, and 36, right? And if we add those together, we get 79. And 36 is 3 times 12, and 5 less than 36 is 31. So that's our check to prove that it's correct. All right, guys, that's your now try. I think that's a pretty straightforward one. One number is 18 more than 5 times the other one, and the sum of those two is 138. So you're going to pause it now. And then we'll come back and work through it. So let x represent the smaller number, or I'm just going to even call it the first number. But since we're multiplying and adding, we know that it will be the smaller number, but I'll call it the first number. And it's 18 more than 5 times. So 5 times the number is x. 18 more than that's going to be 5x plus 18. And we'll call that the second number. All right, so the sum of these two is 138. So x plus the quantity 5x plus 18 is equal to 138. So x plus 5x is 6x. So I get 6x equals 120. I divide both sides by 6, I get x is 20. Now what about this? Well, 5x plus 18 is 5 times 20 plus 18, which is 100 plus 18, which is 118. So I will put 5x plus 18 is 118. All right, so what are the numbers? The numbers are 20 and 118. And if we check it, we add them up, we get 138. If we do 5 times 20 is 100 plus 18 is 118. There's our check. All right, so there it is, guys, your homework. I'm going to be generous, and I'm going to scrape off number 4. All right, if you wanted to do it, okay, I guess I should give you the option, right? So if you really want to do number 4, that would impress me. You can do it. Just make a little note that you did it, so I make sure that I check it out. I mean, I check all your homework anyway, but I would check it, the day of as opposed to a couple days later, so you get kind of more timely feedback. But you really only have to do 1 to 3. All right, and we're going to do the same thing we've been doing all along. Okay, we're going to write our let. You're not going to copy the question unless you really want to for some strange reason. You're going to write your let statement. Okay, you're going to write your equation, and you're going to solve. You don't have to check, but you should make sure it makes sense. So for number 1, if your numbers are 57 and 32, we know that's wrong because it doesn't add to 62, for example. So you're going to do exactly what we did here. You're going to write your let statements, you're going to write your equation, you're going to go back and substitute, and then you answer in a sentence. The numbers are, for number 3, the dog costs this, the frog costs this. All right, guys, any questions, comments, concerns? Of course, you're going to post your homework, write a little comment on Google Classroom, and I will get back to you as soon as possible.